Welcome to Train Signal. You are watching Monitoring vSphere Performance. So in this lesson, we're going to talk a lot about basically one tool, ESXtop, and his brother, R or Remote ESXtop. ESXtop is a tool that's very similar to Unix Top, if you've ever used that. And I say loosely similar because it looks like it, kind of acts like it, but it's pretty different. But at least you'll feel a little bit at home if you've ever used Top. There are two versions. ESXtop runs locally on a vSphere host, so you SSH in the host and run ESXtop. Or if you want to use the remote CLI or the VMA, the vSphere Management Assistant, you can run it remotely using our ESXtop. Same stuff, just depends where you want to run it from. So you can run ESXtop in one of three modes. There's interactive, which is the default mode, and it kind of gives you live updated information. There's batch mode, which captures metrics and dumps them to a comma delimited CSV file for later analysis. And then there's replay mode, which shows information captured by the VM support command. Just want to hit on this. A lot of times when people see this, they think, okay, batch captures data, replay replays the captured data. That's not correct. Those two commands or modes are not related. Batch captures data into a CSV that we dump into other tools such as Excel. Replay actually replays information captured by the VM-support command. This is a command that a lot of times VMware Tech Support will have you run, and it'll basically just spits everything out into a file, and then you point ESXtop to it, and it replays back that information. So don't get those two confused. They are not related. There's a very handy ESXtop performance guide. So this comes out of a VMworld session, and it's really good. It shows you a lot of the different statistics, kind of their thresholds, information on them, and it's really handy. So even if you're not going to use it for the exam, though I'd recommend you at least look through it one good time, if you're a vSphere admin, I'd print it out and have it nearby. Definitely save a copy on your system so you have it. Really useful. We're not going to dig into the individual metrics in this lesson. We hit on those in a couple of others as they're relevant for like network or disk or VM performance or something like that. But I wanted to show you that as we're going through the main tool. So using ESXtop in interactive mode is fairly easy. You just run ESXtop, and by default, it refreshes live information every 5 seconds. You can use the S hotkey to change your refresh time. So a minimum is 2 seconds. It won't let you go nuts at 1 second, but you can change it up or down, whatever you want to do. It just kind of refreshes the information. The reason you might want to do this is because it's really annoying to be tracking something and the way that it sorts stuff and have it jump all over the screen if it's kind of erratic. So you may want to bump it back so you can follow what you're looking at. But again, use the S key. A couple of other keys that are real handy to know. There are different displays in ESXtop. There's a CPU that's the default, shows your CPU related fields, memory shows your memory related fields, network for network, etc. So hit C for CPU, M for memory, N for network, D for disk adapter, basically like your HBA or vMHBA, U for disk device, and ESXtop now includes NFS. It didn't used to, and it was kind of annoying if you wanted to get NFS performance information, but now it does, and that is the actual disk device. And then you have V for disk VM. That will break it down into the VMs and their disks, like their VMDKs, performance as it sees it. Whereas the disk device for you is as the actual device. A couple of other things. Capital V shows only VM worlds. And world, real simply, basically equates to like a process or a thread. We'll show this a little bit more in ESXtop. But a VM is not a single process or thread. It's actually what's called a group. And a group contains multiple worlds. So, you'll expand out. Actually, right there, if you hit E, you can expand out a VM group and show all the little world processes underneath it. And then there's K. K is kind of the kill it with fire key. I have seen this before where a VM had an issue. I actually still run the Untangle system for my home firewall and VPN and all that stuff. And I was playing around with it one time and got to the point where I could cause the virtual machine to actually hard lock and vCenter couldn't touch it. And I'd actually have to go in and run ESXtop and actually hit K, and it'll ask you for the ID, the process ID number. You give it to it and it'll kill it. So it kills it dead. Right? It's not stateful, graceful, kind at all. So use that very cautiously. But if you get to a point that you just can't do anything, and you're at the point of, well, it's either do something drastic or we've got to, evacuate all the VMs and just outright reboot the host, you can go in, use K, and kill that world. Custom ESXtop or our ESXtop profile. So the profile is kind of what ESXtop is displaying to you. By default, there's a set default view with default fields. So when you load ESXtop, as we'll see in the lab in a minute, there's a bunch of columns. So on the CPU screen, again, it shows columns for CPU, for memory. Those are called fields. It doesn't show them all by default. You can pick and choose, enable, disable, or hide or show fields. You can change the field order, all sorts of stuff. So you can basically tweak it like you want it, and then save that. Because if you don't do it, every time you load ESXtop, it loads the default profile. So it's just handy to be able to do exactly what you want to do and then load it as you want it. Creating one is easy. We'll do it in the lab, but remember these steps. You load ESXtop in interactive mode. Use the hotkey to configure your fields. F is add or remove fields. O sets your order. And then you'll press capital W to save the settings. Now remember, this is a Unixy, Linuxy type system, so it is case sensitive. Press capital W to save the settings, and then specify the file. And the next time you run ESXtop, use the -C option to indicate the file you want to load. You can overwrite the default. I don't recommend that because you may want the default one day, but save it to a different name and then just use the -C option. Using batch mode. So batch mode again is where we capture statistics and dump them into a CSV or comma delimited file. And what you do is you have to set a few options. So we have ESXtop -B. -B says batch mode. -A says gather all statistics, which is what we normally do, though you don't have to. You can just gather what's in your profile and specify that. -D is the delay, so we could do 5 seconds, and basically that's saying how often you want to capture your statistics. That is the default like we would normally see in interactive. I don't recommend going too much more frequent than that because you're going to put load on the host, and we don't want to do that. -N are your iteration, so it's going to, every time it captures statistics, that's an iteration. So we do 200 iterations times 5 seconds, so we're going to capture for 1,000 seconds. If you like round numbers for an hour, multiply it out for an hour, whatever you want to do, but just keep in mind that's how long it'll gather. Then we have the greater than symbol, which means we're going to pipe or dump all the information into this file, metriccapture.csv. Then you end up with a file, and you get it off of the server however you want to. One way that I do it, well, two ways. You can use SCP for a secure copy. I sometimes will dump it out, since in my lab I use NFS data stores, which are also exported out over CIFS for Windows, and I just dump it to one of those off the host and grab it from my Windows machine. Again, up to you. But then you use tools for analyzing the captured output. 3 most common: Windows perfmon, because it'll bring in CSV files and give you some pretty charts and graphs. Excel, same thing, but Excel lets you massage the data, do things. Maybe you want to look at averages, mins, maximums, things like that, percentiles. Great tool for that. And then there's a written tool for this called ESXplot, which is very powerful. And the nice thing there is, if you're good with Unix regular expressions, you can filter and dig through for all sorts of information. So that's a neat tool as well. Most often, quick and dirty, I use perfmon. If I actually want to go through and look at the data, I use Excel. And there's a link for the latest version of ESXplot. It's a free tool. You can just go grab that. So now let's jump to the lab. In the lab, we're going to demo ESXtop, create a custom profile, show how to capture metrics, and then import the captured information into analysis tools. So with that, let's jump on over to the lab. So for the lab, we're going to do a lot of this within PuTTY. So I've already SSH'd into one of my hosts. I'm in Optimus. And let's talk about ESXtop. So we're going to run that interactive mode. I'm on the host, which is where I find myself using this most of the time. Most people don't deploy VMA or have the CLI installed anywhere else, so it's easy enough just to jump in. Now, running this in interactive, if you've ever again used Unix Top, this may look a little bit familiar, the overall general layout, but the devil's in the details here, definitely. So let's take a look. At the top, we've got the time. We've got the uptime, so this host has been up 7 days, 15 hours and 42 minutes. Dynamic power management in my lab juggles these things around all the time. 414 worlds. Remember, a world is like a thread or a process. So we see some of those here. We'll show some of these in more detail here in a second. But it's also 13 VMs and 20 vCPUs. Then we have what is called load average. Load average is basically how busy are your processors. So these servers are all single socket with 4 cores and hyper-threading. The way these are split into 3 is 1-minute average, 5-minute average, 15-minute average. So it shows you kind of a trend from furthest to the current conditions. A load average of 1.00 means all of my cores are executing threads. So I've got one thread to one core and everything is very smooth. You don't want that because that would be like 100% utilization on the nose. If I had a load average of 2.00, that would mean I'd have twice as many threads waiting to be executed as I had cores processing them, and I'm way overloaded at that point. So a 0.33 would be a third percent, a 33% or 1/3 utilized, etc. So you want to kind of keep that number in medium, just kind of consider it an overall percentage, just kind of a general guideline of how busy the host is. pCPU here is physical CPU. These are confusing. The reason they're confusing is they try to show the same information, or roughly the same information, in two different ways. So first of all, you notice there's 8 numbers here. That's again because I do hyperthreading. So I have 4 physical cores on these CPUs, but they look like 8 because we sometimes can execute 2 threads per core. So it's going to show that as a split. Then we have the overall average to the right. Utilization basically says, of all the available times to process, information, what percentage of that did we process? So like 17% of the time we did. Used is kind of like a workload metric. How much work did we get done? Now you would think those numbers would be the same. If I processed 80% of the time, I'd get 80% of my possible work done. But that's not really the case. The reason that's not the case is hyperthreading can make it so that you can do more on the same clock cycle, sometimes and sometimes not, depending on the instruction. And also power management. So power management may slow a 3 gigahertz CPU down to 2 gigahertz to save power because it's not being fully utilized. So those numbers will vary. So these get a little confusing. I rarely use these numbers, I'll be honest, mainly because of those things and just the way these are. But they are there. And then you have core utilization, which shows my physical core utilization. So this is, if I got to use one, this is the one I use. About the only time I can see this, these numbers should be roughly equivalent as the scheduler is scheduling things back and forth. But if for some reason you see like 2 cores really hitting hard and 2 that aren't, maybe you've got some kind of a CPU affinity rule set up, which is a bad thing usually, or something like that. But all in all, they should roughly be all working about the same level of intensity. Down below that, we've got fields. So we have field names at the top, and then we have our metrics below. So if we want to change the size of the field, we do a capital L. And remember, this is case sensitive. And it's going to say, do you want to change the size of the name field? Why just the name field? Because all the others are already sized for maximum value. But my name field may be getting cut off, like down here in some places. So sure, let's change that to 20. And you'll see expand that out, and you can see more stuff. Overall fields, we're not going to go into individual metrics in this lesson because we hit on different ones for different things in later lessons. But I want you to get an overall feel of ESXtop. So we have ID. This is your world ID and your group ID. So you notice most of these are one-to-one. And the reason for that is because a VM, such as vCenter, is actually a group of worlds. So if we want to expand that guy, we hit lowercase e, and it says give me the group ID, which is 9095. And it blows up vCenter into all its individual worlds, which each one has a different ID. So you can see like each vCPU gets its own world, SVGA gets a world, MKS, which is your monitor keyboard, gets a world, etc. If you want to kill one of these worlds, you can hit lowercase k, and it says give me the world ID. Remember, it's going to kill it. It doesn't statefully do anything, it just kills it. So only do that if you've got a VM that's hard locked and you can't do anything else about it. But you can do that. You can sort your fields by different things. If you hit question mark at any time, it shows all your hotkeys, the stuff I'm showing you right now. But it also shows sort by. So in the CPU screen, which is the default, we can sort by used with capital U, capital R is ready %, and capital N is group ID. So if I do capital N, it resorts everything based on this ID. Now that does change. So we can hit M for the memory screen, disk for disk adapters, U for disk devices, and V for the VM disks. But as we go through each one, if we hit the question mark, this sort by changes because you can't sort on CPU metrics in a disk display. So it will change, and you can go in there and say, okay, I want to do it by reads per second, which is lowercase r, and it'll do it that. Just remember, these are case sensitive. So lowercase r is reads per second, capital R is megabytes read per second. So it does matter. Go back to CPU. Now, we have a lot of worlds on this screen, so there's a lot of system stuff, a lot of kernel stuff, FT, vMotion, drivers, etc. If you just want to see VMs, hit capital V, and it gets rid of all that stuff and just shows your actual VMs. And that's a lot of times what you want to see because you're trying to pinpoint a VM problem. So you can do that. If you don't like the fields that you see because you're not seeing all of them, a little handy-dandy tip is the higher your resolution, the more stuff you get to the right. Unfortunately, I still have to do these videos in 1024 by 768. Often when I run this, if I'm remoting into a customer site, I'm on a 27-inch iMac or my MacBook Retina display, and I've got fields for miles. But I can't do that here. So to do that, we hit lowercase f. And at the top, it shows your field order, but you can't change that here. We'll see that in a second. But it does show the available fields. Again, these vary by screen. If I'm on the memory or disk device, these are going to be different. Anything with an asterisk to the left is being displayed, such as ID or group ID. Anything without is not. So let's say we want to change the leader world ID. We hit C, and it puts an asterisk beside it. We hit Enter, and it takes us back, and we now have our leader world ID right here's the third column. Maybe I don't want that third column, or maybe I like to have my name to the left, not the ID. For the changing the order, we hit a lowercase o. And now we can change the field order. So anything up here in caps is being displayed, A, B, C, D, E, F. Anything in lowercase is not. You'll need to go to the F screen to turn those on, but you can set order here whether they're on or off. And the way you do it is, say, for like the name, which is D, if I hit lowercase d, it moves it to the right. See that at the top? If I hit uppercase D, it moves it to the left. So it's uppercase and lowercase of the one you're moving. So I moved it left, hit Enter, and now it's to the left. I kind of like this. I like the way this is set up. I want to save this to a custom profile. Well, then I hit uppercase W. It says, hey, what do you want to name the file? So by default, we can name it as .esxtop50rc, and that's what it'll pull in every time. But if you want your own custom, you just name it whatever you want, like .vcap-demo. You don't have to do a dot, but in Unix, a lot of times config files have dots in front of them because if we just do an ls and display the files in my home directory, things with a dot in front don't show up. So if we have a bunch of config files, I don't want them kind of muddying the waters. So we hit Enter, and it wrote the config. So I'll hit Q to exit. I'll type ls. I don't see anything. ls-a for all, and we see our vcap demo here. So if I want to run that next time, it's esxtop-c.vcap demo, enter, and it pulls in our config like we had before. Notice it does not do things like make it VM only, stuff like that, but it does pull in our fields in our order. So let me do question mark, make sure there's nothing else that I need to show you. Delay is a good one. S, by default, it updates the screen every 5 seconds. The lowest you can go is 2. If you try to do 1, it's going to say no. I'm going to set it to 2. If you're trying to track something on a metric that keeps jumping around, you may set this higher to like 10. Again, that's up to you. You can limit display to a single field. So you'd set a single group ID, like, again, vCenter, which is going to just show that. So I probably want to expand that out. But if you just care about vCenter, you can limit that and only watch that. If you want to set it back, hit lowercase l again and 0, and it resets it. So that's pretty handy to pinpoint in on a specific VM. So let's see, that is interactive mode. Now let's take a look at batch mode. So we want to capture some statistics and dump them to a common delimited file. Real easy. There we go. So esxtop-help, I just like to show you and expand these out. So esxtop-b for batch mode, right here. Then we need to set our iterations and delay. So -d and -n. So let's see, delay, we want to capture statistics every 3 seconds. And we want to do, I don't know, 10 iterations. So it's going to capture every 3 seconds, 10 times 30 seconds. So we do that. And I like to do -a to capture all statistics. That way, if I don't come back later and go, oh man, I wish we'd gotten that. So we got to go capture again. Well, just dump it all out. Greater than sign, because we're going to dump it to a file. I'm going to dump it to one on a data store that I can get to. Volumes, data store 01, and vcap output.csv. So that is going to dump that out, and then we'll go ahead and pull that into some tools. So we've got 3 tools that I'm going to show you. We've got perfmon, which is built into Windows, esxplot, which is an open source tool that's real handy if you want to do some regular expression filtering, and then Excel if you want to massage the data, maybe do mins, maximums, 95th percentiles, different types of charts, graphs, whatever. Excel is definitely the most powerful. But if you just want some quick and dirty charts like you're looking at utilization over the last week, we can do that easily in ESXplot or perfmon and not have to dig through and, I don't know about you, but every time I do charts in Excel, it's been just long enough that I forgot how to do charts in Excel, so I have to learn it every time. So we'll go ahead and let this finish, and we'll take a look. And while we're waiting, we'll go ahead and at least load perfmon. How about that? Perfmon. And the way we do this is Windows 8 perfmon. We go to Performance Monitor, go up here to View Log Data, go to Log Files. We will add the file, and then we give it the path, which is lab station for my lab, data store 01. This is exported out over CIFS as well, makes it really handy. And I actually got one from last time when I did this, so we'll just use the one I already got last time. Grab this one. Hit OK. It'll show you the time span, and then it goes blank. So we'll do a plus sign, and it shows the host here that it pulled in out of the CSV file, and then all of our counters. So let's do CPU. We'll expand that out. You can also basically add all of it if you want to, all instances of the object. We'll go back to Mr. vCenter, VM 9095, add him, hit OK, let it process for a minute, and it shows all the CPU counters that we pulled in. So it's good stuff. Shows my chart, shows my graphs. We can go in here one by one and deselect or add and make the chart do what you want. Again, simple stuff, nothing too complicated. Yeah, something's going on with that output. Let that finish again. But we'll keep moving since I already have one ready. The next is ESXplot. Again, you can download this for free. If you've never used regular expressions, they are really crazy, powerful, yet complex filter commands that I'm not going to get into now. I've yet to have a need to do this with output from ESXtop. I'm sure somebody does for some reason, but I have not. But it's great, again, for doing simple charts and graphs. Come to File, Import, Dataset, scroll to the bottom, and we'll do Capture. It'll import, show the host here, give it a second, and double click that guy, and it expands everything else out again. So you can go through, pick and choose. It's got all sorts of stuff, basically split out by the different components, memory, whatever. Scroll down to 995. vCenter, expand him out. It'll redraw again. Then you can pick and choose your metrics. So we'll do CPU latency, and it shows a chart for that. Simple, easy, especially if you want to do regular expressions. You can type those in, hit go. But it's a quick and dirty tool for charts. My favorite is Excel if I need to do something. So we go to Excel, to Data, from Text. Punch in my lab station again. And we'll look at the capture command. And it is delimited. Next. It is not tab delimited. It is comma delimited. Next. And default, so we just hit finish. It's going to say, do you want to do an A11? Yes, and it's going to tell me that I captured too much stuff, so it won't fit on a single worksheet. You can actually go in here and say, import again into another worksheet and exclude data that's already been imported. But what I want to show you is it's basically your fields across the top, and then your iterations here along the side. And you can do all sorts of stuff. So we can go here and do, say, give me the average of all this, and it'll show you the average for that. So if you want to do 95th percentiles, or you want to do mins, maximums, sums, you want to do fancy charts and graphs, you can do that with an Excel. So if you want to do anything with the data, it's all about Excel. If you just want quick and dirty, it's usually perfmon or ESXplot. And obviously I've done something wrong here that I'm going to look at in a minute and go, oh yeah, that was a terrible demo, because that guy is not finishing for some reason. So enable batch mode, done, -D for delay is 3, -N. Oh, I did I. That's what's wrong. That's what the problem was. So let me just show you real quick, and I'll show you why I did I in a second. Output 2. That's what's wrong. Luckily, I already had a file ready, but that one will run for 30 seconds. So make sure it's -D for delay between updates. So it kind of takes a snapshot every 3 seconds. And then N is your iterations. And I said do 10 iterations times 3 seconds is 30 seconds. So this is batch mode. Next, we're going to do replay mode. And when we do VM support, it is -I. That's where I was confusing myself. I wish they would sync these two things up, and it's done in 30 seconds like it should be. So let me show you replay mode. So again, to capture data for replay mode, we do not use batch mode. Replay mode does not pull in CSV content. It pulls in information created from the VM support command. So I'll do help. So to do this, we do -P because that tells it to capture performance data. By default, it does not. And then it's a little bit different. So first we do -d, here it is, for duration. This is not delay, this is duration. How long do you want to capture data? It's in seconds, so 300 seconds, 5 minutes. And then your interval. See why I was doing -I a minute ago? Interval is interval between snapshots. So this is like delay in ESX top. How often over this 5 minutes do you want me to capture snapshot data? I don't know, every 4 seconds. So my suggestion, like you just saw, is if you get one of these questions in the exam to dump out a CSV or dump out VM support, is pull the help up and then actually look at it, unlike what I did up there for ESX top, and then go through the right options. But again, duration, interval. I also highly suggest you set working directory with -W, because what's going to happen is it's going to produce a bundle that is about 300 meg in size. And if I do that here on a local temp directory, which is where it puts it by default, is /temp, I'm going to fill the space up on this server, and it's going to not work. So I suggest dumping it to a working directory like a data store, and then it'll go. So if I hit this and kick it off, which I'm not going to do because I've already done this, because this takes probably, I don't know, it's going to capture data for 5 minutes, and then it's got to capture a ton of other log file and information. It's going to run for a while. But I suggest make sure you do -P, set your duration, set your interval, set your working directory, and off it'll go. And it'll tell you the file name it's going to create, but I'll show that to you here. VMFS volumes, data store 01. So if we do an ls, we see there's an ESX Optimus because it has the host name, it has the date and the time, and it creates what's called a tar-gz. A tar-gz is a tar-gzipped file. A tar file in Unix, if you're not familiar, is a concatenated group of files. So if I have 50 files, and I don't want to manage 50, like I don't want to upload 50 to a website, I can tar them together, which basically takes 50 of them and puts them end to end. It doesn't compress them, just makes one file out of them. Then I compress it using a separate command called gzip, and that's where we get a tgz. So it tars them together one file and gzips them up so they are compressed. So if we want to actually do a replay, we have to uncompress them, which is tar xvf, gzip tells it to ungzip, extract, verbose so it lists it, and I think F is file. I believe that's right. And off he goes, and he'll uncompress it to a directory. And then there's one other command we need to run called reconstruct, and I'm going to explain this real quick, mainly because I've seen documentation for using replay mode where they leave this step out, and you get an error that I'm going to show you. I've seen this error, 1, when you don't run reconstruct, and 2, when you're creating a VM support file, but you run out of disk space, and you're like me, and you're not paying attention because you kick off the VM support, go do something else while it processes and comes back, and don't read the output, and then you try to run a support or a replay against it, and the files aren't there because it couldn't continue. So I'll show you that. But it's been a long time since I've done a replay mode in anything older than version 5. So I don't think reconstruct you used to have to do, which explains why some documentation that's just been copied over from 4 to 5 misses this step. But if you don't do it, it will not work. So I'd hate for you to get into the exam and they tell you to get ready to do a replay mode and you forget this single little step. So now if we do an ls, we see a directory with the same name as our file, but without the extension. So change into that directory. If we do an ls, there's the reconstruct command. If you're not familiar with Unix, you can't just run this command. Why? Because Unix doesn't run commands out of your current directory by default. The only where it looks in your path, so your path variable. The reason I'm harping on this is you may get in the exam have to do this, and you're like, well, it says it's not found, but it's right there. What you need to do is do // which says run this out of the current directory, reconstruct.sh, and this will take a few seconds, but this reconstructs the data, these snapshots. Oh wait, I was going to show you what happens if you do it without running that, so hopefully I didn't already get too far. ESX top dash help. And replay mode is simple. It's just dash capital R. Enables replay mode, and then you give it the path to the directory, not the TGZ file, the directory. And so we get this error, which basically says all VM snapshots have been used. So that means I need to run reconstruct. So again, give this a second, and then we'll run replay. Replay mode is just like interactive mode, but it's not pulling in real-time data. What I mean by it's just like interactive mode is you can change your fields, you can change your order, you can go to VMs, you can expand your groups, you can do about anything as long as you capture the data, which is why it's pretty handy because it runs just like it. So if you capture an hour's worth of data, you can sit there for an hour looking at information just as it came in. So it's pretty neat. The only, again, downside, and it tells you at the bottom, I'm reading in data from such and such file, is that it's not truly live. So, if you miss something, it's not going to be there. All right, and now again, we just run ESX top dash capital R with all of our good path to, again, the directory. Hit enter, and it may take a minute for this to churn depending on how much data you captured. This wasn't too much, so it's not bad. But again, at the bottom, it shows where it's reading information from. And this is pretty much, updating and going through the replay data. So I can hit F to adjust my fields. I can hit O to change my order. I can go to the memory screen, disk adapters, go back to CPU, only show VMs, etc. Just like you would in regular ESX top, but it's pulling it out of the replay information. So if you get this question on the exam, I don't think they're going to actually replay the information because there's no way to track that. You often hear me say this is a great exam question or probably not a great one. The reason being is this is a lab exam and data just finished and it dumped me out, or you can hit Q to end. But the reason I say that is it's a lab exam. So nobody's watching over your shoulder while you take it. But what they do is look at the output when you're done. So anything like creating the VM support files, creating the CSV files, that's actual, data that they can look at and make sure you did correctly. So, but if you do get asked to create this and you do have time, I'd highly suggest you run the reconstruct and you actually do a replay to make sure your data is good and valid. So that's it for the lab. Back to the deck. And that's it for the lesson. Good stuff here that we're going to build upon as we look at some of the more interesting metrics as we go through the later lessons. But what I want you to know how to do out of this, know how to move around ESX top, know how to change your fields, know how to change your order, know how to dump out a custom profile, know how to read it back in to make sure you did it correctly, know how to do batch mode and create a CSV file, and know how to do a VM support performance capture so you can do a replay mode. And so those are very specific steps, very actionable items within the exam, and something you definitely want to know how to do. But that's it for this one. Look forward to seeing you on the next lesson.